InterFET, the low noise JFET specialist. In this video, we will simulate a JFET amplifier with QSpice. This is how the QSpice program looks when first launched after you dismiss the quick tip screen. We will build and simulate a JFET common source amplifier. To do so, we'll need a JFET. Luckily, QSpice has some built-in JFET symbols. In the menu on the left-click on the plus sign just to the left of the text built-in symbols. Now slide down to the letter J and expand it by clicking on the plus sign. There are three options for JFETs. Select the N-channel JFET symbol with a left click and then push and hold the left mouse button to drag it onto the schematic canvas and then release the mouse button. Now, right-click the JFET symbol to open a menu and slide to the bottom, then left-click to bring up the selection guide. The JFET selection guide is a table-based part selector with several columns of part parameters. Click on the title of the leftmost column to sort the parts based on part number. You can now use the slider on the right or the mouse wheel to move down through the column. Let's select the IF1320 by selecting anywhere on that row and clicking OK. The part has now changed to the IF1320. Use the mouse wheel to zoom out a little so we can place the other parts of the circuit. Just press the R key to call up a resistor. It will be attached to the cursor. Position it in the desired location and right-click. You are still in place resistor mode, so another one will appear and move with the cursor. Place R2 below the JFET. Place R3 and R4 to the left of the JFET, and place R5 to the right and down a little. Instead of placing R6, press the C key to transition to place capacitor mode. Hit Ctrl R to rotate the current component and place C1 to the right of the JFET, then immediately place C2 to the left of the JFET. Move back to the right of the JFET for C3, but hit Ctrl R again to rotate it. Now we will add a voltage source to power the circuit. Instead of placing C4, press the V key to change to place voltage source mode. After placing V1, immediately place a second voltage source just below and to the right. Now move to the bottom somewhere and transition to place ground symbol mode by pressing the G key. After the ground symbol is placed, press the W key to enter wire mode. The cursor will become a dot. We will wire the circuit with a left click and then move to draw the wires. It is efficient to wire over components and let the software connect the components. The circuit is now complete, so let's provide some values for simulation. The supply V1 will be 5 volt, so double left click on the val text near V1 and then type 5V, then enter. Double click left on the word val to change the value of the V2 to sine and follow this with the numbers 0, 0.15, and 1000 to set the sine wave parameters at no offset, 150 millivolt, and 1000 hertz. In a similar manner, change the value of the capacitor C1 to 10 microfarad. R3 should be 2K and R4 should be 250 ohms. Make R1 700 ohms and R2 will be 250 ohms. Go back and change the value of R4 to be 175 ohms by double-clicking the erroneous 250 and hitting backspace to erase it, then type 175. Moving on, change C2 to 10 microfarad and R5 to 10K. Now all the values have been entered and the schematic is ready to simulate. However, let's add some reference names so we can do some calculations. Right-click on the net between C1 and R5 to bring up a menu and select Label with a left click. A small red dot with the text will attach to the wire. Double left-click the red text. Use the backspace key to empty the net name and then type VO for voltage out, then hit enter. Now add labels between C1 and R1, between J1 and R3, and between J1 and R2. Change these labels to VD, VG, and VS for the voltages on the drain, gate, and source respectively. We need to provide the simulator with some commands for what we want it to do. Let's tell the simulator that we want to perform a transient analysis. To do this, type the period key and then just start typing the command word tran and follow it with 0.01, then enter. Let's also tell the simulator to plot out some waveforms for us. This is done by typing the period key and then plot, followed by a capital V, then the signal name in parentheses, in this case, VO. The capital V is for volts. Let's also plot VG since it is the input signal to the JFET. Again, use the dot plot command followed by a capital V and then VG in parentheses. We can also have the simulator measure some signals for us. We will break these into two categories. The first is static conditions and the second is dynamic conditions. We will create a dot command that we will then turn into a comment. Hit the period key to signify a simulator command, but do not hit enter, just typing the words static conditions. Hit enter. This is an invalid command, so if we tried to simulate, it would produce an error. Hover the mouse anywhere over this command and press the semicolon key to change the command to a comment. It will turn blue. To request a measurement, again hit the period key and start typing the word measure and follow it with a name, in this case VG, then a space, then the capital letter V, and the net name VG in parentheses. Use Ctrl-C, Ctrl-V to copy and paste this command 2 times just below. Change the second command to measure VS, and for the third command, let's use a mathematical expression to calculate VG minus VS. This command is measure, followed by VGS, then the text VG minus VS. These static measurements will be useful if you need to know the DC voltages in the circuit. Create a comment by typing the period and following with the text dynamic conditions, followed by enter and then semicolon. Beneath that, we can paste the command used above and change it to measure VO, but add the key letters PP to indicate peak to peak, then followed by the capital V and the signal name VO in parentheses. Let's repeat this command for VG, again using the capital letters PP. Finally, let's paste the command again and change it to calculate a new signal called gain by dividing VO by VG. Now all our simulator commands are complete and we are ready to simulate. Right-click on the canvas somewhere to bring up a menu. Select the top item, Run Simulation. The simulation will begin. A new window will pop up showing the waveforms for the signals that were requested with the plot command. The output window will list the file name and the runtime. Then it will list all the measurements we defined above. If there is an error in syntax or a signal name, the simulator will let you know. Let's look at the results. Looking at the graphs, we can see that the output sine wave is about twice the size of the input sine wave. The output is also out of phase with the input. Looking at the output window, we can see that the values we have requested have been calculated. The next step would be to change component values and simulate again. If you enjoyed this video, give it a thumbs up and subscribe for more expert insights into JFETs, analog design, and low-power electronics. Hit the bell icon so you never miss an update from InterFET. Got questions or ideas for future videos? Drop them in the comments. We'd love to hear from you. Interested in using JFETs in your next project? Reach out to us directly through our website or the link in the description to speak with our team of experts. Stay connected, stay curious, and keep innovating with InterFET.